Welcome to Introduction to Machining Plastics. We will be talking about the basic principles of machining, and these apply to machining of any type of materials, but of course we will be focused on plastics. This presentation is designed primarily for less experienced salespeople or for salespeople who are not familiar with machining processes or terminology. Hopefully, those of you who are more experienced will find this useful as well. The general term machining simply means fabrication processes that use a machine of some type. So it is a very broad term. We will talk about those processes that are important to our customers and therefore important to us. The three most common machining methods by far are milling, router cutting, and turning. Milling uses milling machines or machining centers. Router cutting or routing uses routers of various sizes and types, and turning uses lathes or turning centers. We'll show examples of these different machines and their operation in this presentation. It's important to mention here that there are many other types of machining operations, such as boring, drilling, reaming, broaching, tapping, grinding, planing, sawing, and many more, but they all fall under the general term machining. And most can be done on one of the machines mentioned previously, and some can, and in some cases need to be performed on simpler, more specialized types of equipment. For example, drilling of holes can be done on a basic drill press like the one you see here. But truly precise work is typically done using one of the machines mentioned previously: mills, lathes, or routers, or machining centers or turning centers, which can all perform precision drilling as well as many other operations. All machining methods share one common aspect. They all remove material from a workpiece, often called a blank, in such a way that the remaining material takes the desired shape, the shape of a finished part. With rare exception, all plastic machining processes will start with a workpiece that is flat or round. In our world, that translates to workpieces from sheet or plate, rod or tube or tubular bar, like those seen here. The terms tube and tubular bar in machinable materials are used interchangeably. For the most part, the term tubular bar refers to thicker wall profiles, like is common with cast nylons. Precision machining, like we are talking about here, the type of work that many of our customers do, is capable of producing parts with dimensions on the geometrical features of plus or minus 5/10,000ths of an inch. That's right, 4 decimal places or a half of 1,000th of an inch, and even closer on metals. But plastics, which compared to metals are soft and thermally unstable, are not able to hold tolerances that tight. However, many plastics, in the hands of knowledgeable machinists, can hold tolerances of plus or minus 1,000th of an inch on smaller dimensions and features. Plus or minus 5,000ths of an inch is a fairly common tolerance for plastics and can be held with most plastics at a given temperature. Once a part is machined, of course, if it is exposed to significant temperature changes, it will expand or contract, and that is an important consideration with plastics. Let's take a look at some of the various types of equipment and processes used in milling, routing, and turning plastic materials. All machining involves a rotating tool or a rotating workpiece or blank, or both. Milling, whether manual or CNC, utilizing automated controls, is the most common type of machining in the fabrication world, regardless of material. CNC routing is rapidly gaining on milling as routers are being produced that have constantly improving capabilities. But let's start with milling. But before we get started, let's make sure we know what CNC means. CNC stands for Computer Numerical Control. CNC equipment is very common today, but is a fairly new technology compared to how long machining technology has existed. Some types of machining, such as wood turning, has been in existence for several hundred years. Basic milling technology dates back to at least the early 1800s. CNC machines, as opposed to manual machines, are automated and have motors and controls that determine the positioning and movement of both the workpiece and the tool on the machine. This allows for much more efficient production of parts than manual machines can achieve. And then there are machining centers and turning centers. Think of these as the most fully automated versions of CNC machines. You will see examples of all of these type machines in the following training modules.